Heidi is the co-director of the Center for Mendelian Genomics, and I sometimes just refer to her as the Queen of ClinGen, though I know she has a much more official title for that, but I like Queen of ClinGen for introducing her to things. So.
And a continued amazing thanks to Sam and to Danielle and others who have really helped pull off this course. It's been terrific. Okay, so I've been tasked with talking, about data sharing. I do have one conflict of interest in some settings, which is NIH funding. So I do receive NIH funding for the work that I will talk about in this context, and a very strong opinion about data sharing, which probably has a stronger influence on the stuff I will present. But most people don't acknowledge their opinions and their roles they play. So I did want to just talk generally about some of the ways we think about data sharing, and in particular, the platforms that we use for data sharing. And I had written a review, when was that? Maybe a year or two ago. And part of that was talking about the concept of centralized versus federated databases. So, for a long time, most of data sharing was either very point-to-point, you just give somebody a piece of data that they want without any infrastructure, or it was all done through centralization of data. And examples would be dbGaP, the NIH platform for sharing sequence data, or now ClinVar, which is a variant database. And in this case, everybody's submitting data into that database physically, and it sits in one centralized database. However, a newer paradigm that's really been taking off in the last few years is the concept of a federated network. And in this case, each of the databases that exist can sit in their own physical space, and they may be in different countries all around the world. And then you set up connectivity between these databases through APIs, or application programming interfaces. And to support an API, you need to define the structure of the information that you're going to exchange so that you can know what you're sending and have the ability to receive that information and make sure it stays in the same format. So you have to agree upon the structure of the API and its content in order to make this work. But this allows a lot more control by the people who have that data in their own databases to control who's getting it, when they're getting it, et cetera, and to track the exit and intake of data. So that's really a concept that we've been working heavily on in terms of data sharing. Now, there are arguments as to why you might want one system versus the other. And in the case of centralized databases, I think a good example of where the added advantage of a centralized database would be ClinVar, where we can really be able to publicly share this information with a very wide audience at any point in time. Nobody has to register and log in and do anything. You just go to ClinVar and you look up a variant. And it also allows us to readily compare information across submitters, and that then allows us to achieve consensus, and it just makes sharing with the community that much easier. That's also true of the Nomad and Exact databases that Daniel's team launched. By bringing all that physical data together, there's a lot more value that they can return to the community by bringing it, jointly analyzing the raw data, and they can provide denominators for how many cases that variant was absent from, as well as where it is. So there are advantages that you can achieve through centralizing the data. On the other hand, there are data sets that just can't be shared in a public way. And that usually relates to very detailed patient-level data. It also relates to international data sharing, where there are countries that have very specific laws about patient data not exiting that country. And so when we endeavored to start thinking about the Matchmaker Exchange, which is really an international platform to exchange patient-level data, we really had to think about the international boundaries and how to deal with those things. And just to be very clear about what we're doing with Matchmaker Exchange, we basically are trying to match, oops, wrong button, trying to match a particular patient who has a particular set of phenotypic features and may have one or more candidate genes that have been identified in that case, and trying to find other patients around the world that have overlapping phenotypic features and may have at least one gene in common of the one or more candidate genes that have been identified. And through electronic means, we can match these patients together and then notify both of the submitters that there's been a match. When we started this project in about 5 years ago at ASHG, we brought a bunch of groups together. Not all of them currently are connected to date. And that's in part because each of these databases was doing different things and had different interests. And so trying to identify what is our primary goal and who has data that meets the needs of that goal and has the ability to stand up an API to exchange data. So we spent a lot of time trying to figure out how we would support this. Would we create, annotate one of these databases as the central and make everybody else put their data in it? That was profoundly voted no. And so we went with this federated model to connect these. And this is what the Matchmaker Exchange looks like today. This figure is on our website, thanks to Danielle, who posts all this stuff. But it contains all of these different nodes that are connected. It's not quite like this. In fact, there isn't one connection to a central place that then federates. It's actually more like the connectivity that I showed here, where you do have to create linkages one by one to every database. And that does create some challenges. The technical teams have to exchange keys with every single database. So as it grows, it does get more and more complex. But that allows each database to decide who they want to share with, and they can exclude one if they want. To date, we haven't had any active exclusions, and everybody is connected. But it allows that sort of granularity of data sharing decision. And the way it works, and this is a slide that Harindra made, one of the sites will essentially send a message to the next site to say, do you have any patients that look like X? Now, the most key thing there is, in fact, sending the gene. Do you have any patients in whom someone has flagged this candidate gene as a candidate? So you're sending a gene over. Now, a lot of people will include phenotype. And so when this node then does an internal search based on that question to find patients that have been flagged with the same candidate gene, if phenotype has been provided, then they can score how good the match is by adding phenotypic data to it. And then that will return an answer to the originating database. So it's a very, and then when that answer comes back, if there is a match, it will send a notification to this submitter, and node B will send a notification to each submitter. So both the submitter and the instigator of the query both get notified simultaneously. And we designed the system this way in some ways because novel gene discovery is one of the most coveted things in the genomics academic space. And so we needed a platform, and I regularly call this platform data sharing for the paranoid, because these people are they found this, they think is the novel gene discovery, and they don't want to just put it out on a public website and have somebody just scoop them and publish the paper without them. Now, I actually do support that approach, but not everybody does. And so this way, we could get more people willing to share their data because they knew that the only people that would find out that they have this candidate are others with the same candidate. And the only way those two cases are often get it published is they bring the data together. So this is sort of this dual notification that allows then both groups to collaborate. And Sam showed some of the exchanges, because usually exactly as she said, what happens after this, you've got a match, it's then, all right, tell me the exact details of your patient so we can figure out if this is a real match. Okay, and today we support gene phenotype matching, and that could be one very strong candidate, maybe a de novo variant in a gene that's never been associated to disease, but only one case. Or maybe you've got a bunch of rare variants in a bunch of genes. None are great candidates, but you're fishing for matches. And unfortunately, the weaker those candidates, the more false matching happens that you have to follow up and go, oh yeah, this patient has retinitis pigmentosa and that patient has seizures, not a match. So although sometimes people will then go into depth and discover that that eye disease patient who showed up in the eye clinic actually has seizures, and that seizure case that show up in neurology clinic actually turns out to have eye disease. So, at first glance, some of these don't look real, but then sometimes you actually dig a little deeper and they turn out to be real. We do have the capability to match on phenotype only, though it's rarely used. As Melissa will talk about, we can match on non-human models, and we do have patient-initiated matching, which I'll mention a little bit later. These are the overall stats for the Matchmaker Exchange to date. There is data from over 85,000 patients across the various connected nodes from over 4,000 contributors from over 73 countries. These are the number of unique genes that are flagged up there for matching within these systems. Probably the most widely used system because anybody, including all of you, can just get a login, go in, and enter a case with a gene. So it's open to the public to do matching. And this is the stats over the course of the last 4 years in GeneMatcher, where they now have over 21,000 submissions, and there's been lots of genes and matches across those submissions, and this just shows the entire world in terms of where this data is coming from. So a very international effort, and in fact, this effort has led to hundreds of publications, either with matching within nodes or across nodes in the Matchmaker Exchange. So to contextualize this a little bit, we thought we'd show you a little video for, whoops, that didn't work. Let's see if I can get this. Oops, I think I have to go push this over here. That is not working. Put the wrong one over there, did I?
Justin was diagnosed at 3.5 months of age.
He was having some delays with his development and also some differences in his movement.
His imaging showed that there was a problem with the way his myelin, or the coating of his nerves in his brain, had developed, and he was given the diagnosis of a disease called Pelizaeus-Merzbacher, which is a hypomyelinating disease.
Around 13 years of age, the neurologist at Children's Hospital of Eastern Ontario realized that he had surpassed what we thought he would do.
Over time, it became apparent that he didn't fit the clinical disease at all.
When we were teenagers, they realized that he was misdiagnosed at birth.
A lot of his nerves weren't conducting information properly, but despite that, he was still able to learn to walk, learn to express himself differently.
Justin actually continued on. He just was not letting go. Despite the dark diagnosis, we knew that he's okay. He's actually working through this.
We were just learning how to do exomes. We were just learning how to manage all this data.
We waited a long time for the results, and they found something on a gene, but weren't sure. They needed some more research.
It came to a point where we had to seek other options for genetic testing because it wasn't clear as to what he actually had.
His clinical presentation being so unique. For many years, people really putting all their efforts to try and figure out what he has and not being able to come up with an answer.
They identified the USP7 as being one of the genes that was responsible to his disorder.
We put that gene into the Matchmaker Exchange, went back to the data, and we really took a close look. We identified another new change in another gene involved, and again we put it into the Matchmaker Exchange, and we're able to match with families in the Netherlands and also with Australia. All those kids, all those individuals who we matched with, all had the same degree of hypomyelination as Justin.
While the rare disease community embraces a culture of sharing, what we have been lacking is the infrastructure by which to do so. And the Matchmaker Exchange and groups like the Global Alliance for Genomics and Health is providing that infrastructure to exponentially increase the rate of our discoveries.
We got one diagnosis when he was 3.5 months old, and then for 13 years we live with that, and then we get told that's wrong, and then we wait 6 years to get a new one.
The family's gone through a lot over the years, and I think they just needed an answer and some closure.
It's made all the difference.
And for other families, it gives them a starting point.
having the match, coming up with the diagnoses, the family was able to look forward and really focus on Justin, making his life as happy and healthy as they can.
The fact that I could even put a face to that person across the country who figured out why Justin is so special is amazing.
I think it's important for all geneticists to know how important their work is.
All of the families that have been involved in our national projects have elected to share their data through the Matchmaker Exchange because they're all seeking the same thing, which is diagnostic clarity.
Matchmaker Exchange made those connections with the other groups, and we had answers within hours.
If that didn't exist, then we would think we're the only family in the world.
It's extremely important that physicians and researchers share information both from the clinical side of things as well as from the genetic side of things.
To find other children to see what makes them unique.
They don't want a similar family to undergo the same experience.
There's other people out there. Having that support is so important.
It makes a tremendous difference for families.
The larger the database, the more data that we get, the more that we can share, the better we're going to be off.
The majority of patients with suspected rare disease after genome-wide sequencing are without a diagnosis. For a subset of these patients, finding an additional patient anywhere in the world with an overlapping clinical presentation and a variant in the same gene can facilitate their diagnosis. But the problem that we face is that these data sets are siloed.
Collaboration and sharing of genetic information is now allowing families to come out of those silos and connect with other families and connect with other clinicians and really giving them a different quality of life. I can't express how important this is.
For us, the fact that he has a diagnosis means there's potential answers out there. But besides that, he is who he is, and without a diagnosis, nothing changes. Like, he's still Justin.
Justin is incredible. He's beautiful. He's perfect. He's perfect the way he is.
Man, that always makes me cry every time. But I think, it really highlights the fact that this is making a difference in a lot of people's lives.
I just want to tell you right now.
Yeah. There we can bring up, okay, I can't get this out. That'll get your cries and tears out of your system. All right, moving on. So it really does, make a difference when we can actually bring these families together and build the evidence. Now, to date, all of the Matchmaker Exchange, and although there have been hundreds of discoveries that have made across the network, it only has worked to date if you already identified the candidate in your case and could then load it into Matchmaker Exchange. What we are working on, and we call that two-sided matching. You both got your candidate and you're trying to fit the pieces of the puzzle together. What we are working on right now is one-sided matching. So you can go in and say, I have a candidate, but for databases where the raw data has been loaded up to the system, so here at Broad, in our Matchbox system that Harinder has built, we have the raw data sitting in the Seeker database that's connected through Matchbox. And so we can actually allow querying into our database and the raw data to say, is there a rare variant and a matching phenotype in any of our cases, even if we haven't flagged it ourselves? And so that is the platform that is actually coming soon. The technical teams are working on this. Eventually, we would like to get to zero-sided matching. Nobody's come up with a candidate, and only through aggregation of all of these cases can we actually find enough evidence for matching. To do that, we really need a slightly different platform than this, sending one query at a time, which really gets to a lot more effort that I'm not going to have time to talk about in depth, but where we're really trying to gather raw data from lots of projects in ways that we can compute across it, look for, do burden studies where we can find signals by bringing lots of cases together. And in fact, a lot of the large-scale data sets that NIH has funded, they've really decided that dbGaP is really insufficient for doing a lot of this work. We need a cloud-based platform that can really support many different types of analyses. And they've just funded a new platform called Anvil, which I'm happy to say the Broad won this award. And so this platform will be built here at the Broad on the cloud platform and allow bringing lots of data together for many different users to compute on and bring their tools to the data so that it can be shared in much more robust ways for discoveries. So that's in the works. One of the innovative things that, and I think Moran may be talking about this in one of the workshops, is the use of the Duos platform that's been developed here at the Broad. And just very briefly, one of the fundamental challenges in thinking about data sharing is matching the constraint applied to that data by the consent process and what is allowable versus what users want to come in and do with that data. And some data sets are consented for very broad purposes, sort of any sort of disease or trait query by anyone, commercial, academic, anyone. But other data sets have constraints. This data set can only be used for diabetes studies, or this data set can be used by academic researchers, but not commercial entities. And as much as we try to make data as open and accessible for all purposes and for all users, there are constraints that are put onto these data sets through the consent process. And so in order to deal with that, we need to be able to structure the uses and allowed uses of the data and compare that to the users who want to use that data. So the Duos platform is essentially structuring the input and the requests in ways that there can be a match that then allows the data sets that are matching to the use and the allowance, and then automatically delivering up access to that data. And so that makes it much more efficient to actually share this data. So I think Moran in the workshop will talk a little bit more about Duos. The other thing that this whole structure of Duos and the concepts that have been developed for structuring the consent codes to document what uses, that's all been developed in collaboration with the Global Alliance for Genomics and Health, which has really been an organization over the last, I guess it's been probably 4 or 5 years now, about 5 years that the Global Alliance has been around. And the goal really is to enable responsible genomic data sharing for the benefit of human health. And it does that by focusing on the standards and policies and other frameworks that are needed to allow data to be shared. So it's not actually doing the data sharing, but it's really defining what it is we need in terms of toolkits across both data toolkits, regulatory and ethics, security. And it's a very large group now. We've got over 500 organizations that are members of Global Alliance, as well as over 2,000 individuals who are part of it from 71 countries. And the current framework of how we operate is really to define work streams of data discovery, large-scale genomics, data use and researcher, I forget what I stands for, cloud, oops, we're missing a couple here. There's a genomic knowledge standards, and the last one is, I can't remember, but there's another one. But then we've defined driver projects, which are well-supported, well-funded genomic programs across the world that are in need of and implementing unique and robust approaches to accomplish their goals that include data sharing as a component. And you heard about Matchmaker Exchange. I'll talk in a moment more about ClinGen, and you'll hear from Melissa about the Monarch Initiative. All three are driver projects of the Global Alliance. And each of the driver projects interacts with the work streams in ways that might be very deep. They're contributing to the development of the standard, or more passive, they're simply saying, I don't want to do work, but please deliver the standard to me and then I will adopt it. So you can see for ClinGen, we are contributing to 2 of the work streams, but we are willing to adopt, phenotype is the last one, adopt whatever is developed in those work streams, for example. So I encourage you to become active in the Global Alliance if you're interested. So now I'm going to switch over to ClinGen. I think Erin or maybe Marina One of them showed, I think Erin showed our infographic in terms of thinking about the work that we've done, that we do, and all the different platforms. I'm going to talk a bit about the variant aspect, particularly in terms of data sharing and how we support ClinGen's goals through data sharing. So, one of the things is the use of common standards, and Stephen talked about the development of standards for interpretation. I'm now going to focus on public interpretation sharing through ClinVar. And in my mind, this creates a lot of transparency to what we do, and it also crowdsources the work. And in fact, many years ago, about 7 years ago, when we first started discussing the concept of allowing clinical labs to share their variant interpretations, the whole goal was that we were, next-gen sequencing was launching. We were all overwhelmed with the number of variants we were trying to assess. And we were all essentially duplicating the same work, trying to find the papers, gather the data out of them. And we thought, if we all just share, what we've done, we will all get there a lot quicker. And so it was really crowdsourcing the work that was the initial motivation. Now later we discovered, as we started sharing, that our interpretations weren't always the same. And that then added another value, which is to identify where we are discrepant and then allow us to actually resolve those discrepancies. In terms of what has been shared to date, so this is a little out of date, a few weeks out of date, but at that point there were over 676,000 submissions on over 428,000 unique variants from 976 submitters from 64 countries in ClinVar. And you can see a map. They're coming from all over the world. Down here, I made a little pie chart of kind of the type of data that is mainly in there. And we've worked very hard to work with the clinical laboratories in terms of submission to ClinVar, knowing they had probably the largest sets of data with the most systematic interpretations. And so about 80% of what's in ClinVar today does come from clinical labs. Actually, this is a little old analysis. It's probably more than that at this point. But in addition to clinical labs, data can come from anywhere, from researchers, either unpublished or published data, from expert groups, and we'll talk about what's going in there from ClinGen. Clinics can directly share their variants from patient reports, patients themselves, and we'll talk about Genome Connect in a bit. We also bring in data from other databases, so all of OMIM is in there, BIC, CFTR2, Insight, PharmGKB. These are other databases for which the data has been integrated. And one of the reasons that we've been quite successful in the clinical arena is a number of sort of calls to actions and policies around encouraging data sharing, both from the AMA, from NSGC, from the ACMG Board of Directors. That's a commentary I had written in Genetics and Medicine. So a lot of motivation from our clinical and professional societies talking about the importance of data sharing. I think that has made a big difference in the US. We also, about a year ago, launched the lab list on the ClinGen website. And basically the idea was both to publicly recognize clinical labs who do support data sharing and incentivize others to share as well as satisfy the fact that we were getting requests from insurers and providers who only wanted to either reimburse or order tests from laboratories that meet a minimum requirement or a minimum level of data sharing. So we came up with a set of requirements for what it takes or what we expect to get on the list. And to date, there are 17 labs that meet those requirements, 15 of which are in the US. There's actually 2 other labs out of the US. And they're all listed on the website here. We did define some extra bonus achievements that labs can do. Either they have submitted all of their detailed evidence in association to their submission to ClinVar. We only required their data that they have reported out in the last year to go in, but if they had done it for at least 5 years, they got a badge. If they were actively participating in discrepancy resolution efforts, and in fact all of them are, they get a badge. Or if they have a consenting mechanism to allow patients to actively share more data than the clinical labs get, then they got a badge for that. And over time, some of these badges may turn into requirements, but this is sort of where we're starting. And that actually triggered a number of the laboratories that hadn't quite met these requirements to jump in and meet them. So it's been quite successful in terms of pushing labs over the boundary of getting their data shared, and the insurers are now starting to use this list and the providers to decide where to order tests or reimburse. Now that's been quite successful in the US, but if you look at clinical lab submissions by country, it's a little different across the other countries. Now I've been traveling the world talking to other countries, and so I get rid of the US and then I show this figure. So it's not zero. There are other clinical labs in other countries that are sharing data. But one of the benefits of other countries that have national healthcare systems is they actually have a lot more national level control over this. And in fact, Australia has now decided that all clinical labs in that country need to submit to ClinVar, and they're actively working on that, so this will hopefully go up. The UK, been terrible to date with their clinical lab submissions, are also actively working on defining the regulatory framework to allow the labs that have been unsure about their ability to share this data to actually share it, and we think that will make a big difference. And other countries are working on things as well. So I think over time, there will be much better uptake around the world in terms of clinical lab practices. Now, as I mentioned earlier, by sharing all this data in ClinVar, it actually highlights the fact that there are differences in how we've all been interpreting variants. And when we first launched ClinVar with NCBI, who's been maintaining the database at NIH, there was a 17% discrepancy for variants where more than 2 or more labs had submitted an interpretation. So that was a little startling, but we've been really making great progress in reducing the number of discrepancies between labs. And this is just an example. Many of you probably have used ClinVar, probably all of you in this room. And so as you know, you sometimes go in and you see that there are different interpretations from different labs. It is worth always looking at the date of the interpretation, because something's really old, that might explain it right off the bat. But when they're all around the same, that highlights the need to go in and resolve those interpretations. Now, some people don't realize that if you click on the summary evidence, you will then get to the detailed write-ups and the summary of evidence that each of those groups has used to interpret the variant. And sometimes by just reading those, you can see that one lab didn't account for a couple papers, or another lab actually included their own internal data that might account for a difference. So sometimes you can kind of transparently see why there might be differences, but other times it's the same data, but a different conclusion. And in fact, Stephen Harrison, who talked about interpretation standards yesterday, also has been leading our variant discrepancy resolution project. The first round of this was published last year, and it was between, I think I forgot to include the 4 labs here, but GeneDx, University of Chicago, Ambry, and Partners Laboratory for Molecular Medicine. Those 4 labs shared all their variants, identified 242 differences, and were able to resolve 87% of them by all 4 labs reassessing all 242 of those variants. And then sharing their updated interpretations if they updated them. And that allowed this 87% resolution. They also tracked the reasons that the variants were different. Sometimes there was no difference upon examination. It was just the lab hadn't gotten an updated interpretation into ClinVar. That is a challenge. Sometimes it was an old interpretation. When it was reassessed with the new guidelines, it resolved it. Other times there was internal data that one lab had access to from their own data, and the other lab did not have access, and that resolved it about a third of the time. And then other times, which data sources they were using or what were their thresholds for calling variants benign or likely benign that were the basis. All of these variants were resolved. There was another 13% that weren't resolved, and that often was due to things like different opinion about use of functional data, for example. Now, Stephen completed that first phase, but there was one challenge, which was it took about 1 to 2 hours per variant per laboratory to take this approach. Now that there's been a lot more data in ClinVar, more submissions, it's easier to take a more aggregate look at all of the interpretations and then first identify outliers. So if 6 labs say the variant is pathogenic and 1 lab says it's a VUS, well, let's ask the 1 lab to assess it first, see if they agree with the 5 others, and then if they don't, then we'll have everybody, tackle that variant together. And it just makes it a little bit easier to take that first step. So Stephen launched that with 41 of the clinical labs that were submitting to ClinVar, and by just having the outlier reassess, was able to resolve 63% of those. He then expanded that to any lab submitting to ClinVar where the submission type says clinical testing. There was 108 labs sent, and this is still a work in progress, but sent out the first batch, and they have resolved 54% of these. He has been looking at just variants that were in conflict but were not sent any report, and how often were those resolved organically over time, and that was about a rate of 24%. So things are definitely resolving through this process. Particularly for these, the next step is to then go in and have all of the labs share their internal data, because as we found out from this, a lot of the reason for differences was when one lab had data the other lab didn't have access to. And hopefully that will then allow the numbers to increase in terms of resolution. So, what happens when we're trying to resolve or interpret variants? This is just an example of a variant that I was trying to assess for the eMERGE program. Initially, it was a VUS, had some it was absent from EXAC and GENOMES. Computational tools data supported impact, but it was only seen in 1 individual colorectal cancer in his father in 1 paper. But we saw in ClinVar that there were 3 labs that had called this variant a VUS. So we were actually all in agreement on the interpretation. But the fact that this variant had been seen by these 3 labs probably meant they saw it in patients when they were doing testing. And the question is, can we go get that clinical data and actually potentially reinterpret this variant with more data? So we went, I emailed all of these laboratories and got back 5 cases worth of detailed data, some with actual immunohistochemistry data. And in aggregate, we were able to apply lots more ACMG codes and move this variant to likely pathogenic, which then was much more useful in all of the patients that this variant was identified in. Now, unfortunately, that effort took about 3 weeks. And this is just a small subset of the emails in my inbox that were required to exchange all of this clinical information and discuss this. So the question is there a way, although ClinVar triggers you to know who might have data, the actual exchange of the useful part of that data has been happening by email. Not the best system for patient-level data sharing and robust approaches to efficient analysis. So at the recent Global Alliance meeting and we had in Toronto just a couple weeks ago, a number of us began discussing, can we do what we've done with Matchmaker Exchange, where we mostly are just putting genes in and looking for matches, but in this case, put variants in and look for specific variant level matches. Wouldn't you love to go into GENOMES, put your variant in, and those 12 cases that are in there actually get the phenotype data back? And unfortunately, the consent allowance for GENOMES doesn't allow that, but we have other data sets around the world where that is allowed, that level of data sharing. And so we've got a few different groups have agreed to be part of a pilot effort to actually develop API connection between the Genomics England database, the Australian Genomics database, the Canadian Phenome Central database. That's part of the Kim Boycott's group that you saw in the video, in our rare disease program here, to actually pilot an API where you could say, hey, what patients do you have with this variant? Send me back the phenotype information, other variants you found in those cases, indication for testing, any structured data around that patient, their phenotype, and the variants that they have, and send it back and agree to what data can be shared and between which participants. So this is just in the planning stages, but it's a concept that we hope will enable richer evidence level sharing for variant level data sharing that goes beyond what we can share publicly in ClinVar. Now I've been mostly talking about the strategies that we use for sequence level variant data sharing, where it's easy to know that you're both looking at the same variant. It's a arginine to histidine change at position amino acid 331 in this gene. Structural variants are a little more difficult to bring the two parties together because they're almost always slightly different breakpoints. And so Aaron Riggs and Krista Martin and others in our group have been trying to work on CNV discrepancy resolution, despite the fact that the boundaries are often not identical and they can't be just matched the way we do in the sequence variant world. And so but they can look at the level of overlap, and particularly they can look at which genes are found within different regions, and they have been curating triplo sensitivity and haploinsufficiency at the gene level. And by defining whether that is a known, in this case, haploinsufficient gene, then all of the deletions that cover that gene can be moved to pathogenic, as you can see they've done here. So by doing this sort of alignment of different structural variants, looking for overlap, and then interpreting the genes with respect to dosage sensitivity, they can help resolve a lot of the differences in structural variant interpretation. They're also working on a CNV interpretation guideline that will make much a much similar approach to the ACMG AMP sequence variant guidelines, so that there's a lot more similarity in the approach. And so that is a work in progress, but getting close to the end. Where's Aaron? There's Aaron. And this is just a graph showing the number of genes. There are up to almost 1,400 genes that have been curated for dosage sensitivity, both haploinsufficiency and triplo sensitivity, that then can contribute to the better interpretation of structural variants. And all of that dosage data is on the ClinGen website, so you can go and look up your favorite gene, see if we have a dosage score on it from this group. Now, I alluded to earlier that sometimes we don't resolve, or we both interpret a variant, we don't agree with each other. I would say the most common, in fact, this is actual data that we have, and this is from one of Stephen's figures. In terms of the reason there are persistent interpretation differences, the most common one is the interpretation of functional data. You read that paper, you look at that graph or figure or chart or whatever that shows some effects, and one person reads it and goes, that looks great, and the next person reads it and goes, I don't think that was validated very well. I don't trust that data, or that assay, I don't know if that's a perfect match for the biological function of the protein or the phenotype. So, but that's very subjective, right? And so it's subject to different opinion. So this is where we really feel we need to engage experts in deciding, is this functional assay a good assay? What is the prevalence and penetrance of this disease? And all of those questions that inform. And in fact, in our gene curation efforts, a very good example of the issue of functional data is in Brugada syndrome, and it actually also impacts the long QT syndromes, where 20 of the 21 genes implicated in Brugada syndrome have now been disputed, and is largely based on the fact that the primary channelopathy functional assay that's been used to implicate almost all of these genes is now, by a set of experts who work in this field, deemed to be invalid way to assess the function of these genes and any variation that occurs in those genes. And that's what led to almost all of these genes being now disputed. So how do we deal with that? Well, we get these experts together to figure this out. We go through a series of steps for the expert panels to define their membership across many institutions and many different types of background, clinicians, diagnosticians, researchers, et cetera, identify conflict of interest. They develop their disease specification, and Stephen talked about this yesterday. They pilot their rules, and then once we approve them at the ClinGen level, then they can go off and interpret. And as Stephen said, they are modifying certain rules. So SVI is modifying certain ones. We've removed a couple. And then the expert panels are modifying certain things based on gene disease specification like these. We are tracking the progress of these different expert panels on our website. So you can go to our clinical domain working groups and you can see all the expert panels, their status as to whether they're approved yet. There's a few close to approval here. And this is just an example for the RASopathy work group. Once they implemented their specified guidelines, it altered 60% of the variants based on using their disease-specified rules compared to the general rules. And in fact, the labs were able to reach 100% concordance by using the disease-specified rules, which are much more precise and less subjective. And that is now helping resolve the remainder of the discrepancies that the interlab process doesn't always address. And here's just examples of these 3 expert panels submitting variants to ClinVar, where through the submission of their expert classified variants, they were able to resolve 220, 30, and 68 conflicts in their first submissions. There are others that are still remaining, but the expert panels are prioritizing the variants that are discrepant between submitters to go and address those particular variants. Now, it's not always just resolving discrepancies that these expert panels are quite useful for. This is an example of a variant that was interpreted as a VUS by both submitters, but the expert panel, in this case the cardiomyopathy expert panel, which has members of both of these labs on it, got both these labs to share their internal data, and they were able to then move the variant up to likely pathogenic by aggregating the data from the individual submitters. And this is yet another example across the same expert panel, where for these 7 variants, they were all VUS, but then by adding in the unpublished private data from the clinical labs, they were able to move up the number of probands and ultimately the evidence to classify as likely path or path for all 7 of these variants. So this is happening across all of our expert panels, in part because we invite membership from lots of the clinical labs, people who have the data, and the researchers also have this data and are sharing it as well. So that's been very useful. 12 of the 25 of these variants change classification from the internal laboratory data sharing. Now I'm going to give one example. Actually, we are running a little late on time. I'm going to skim through this case. This is actually a case of David Sweetser here at MGH, who had a patient with a complex phenotype, and the exome sequencing results revealed a de novo variant, very suspicious looking for a canonical splice site and a 2-exon deletion. Now, they didn't know the cis-trans configuration of these 2 variants to prove that they were on 2 separate copies of the gene. However, the only disease associated to diaphanous, DIAF1, that was ever out was in 1997, Mary Claire King published the first and actually only, I think, pedigree for DFNA1 as a dominant hearing loss gene. And that's was in OMIM up until this case. And so the patient, however, was documented to have normal hearing, conflicting with the only known pathogenic mutation, which causes dominant hearing loss. As I mentioned, the cis-trans configuration was unknown to actually know if both copies of this gene were disrupted. They then searched ClinVar, and at that point in time, they found this one case that had a truncating mutation submitted with actually a phenotype that looks much more similar to Dr. Sweetser's phenotype, and they classified it likely pathogenic. They reached out to this group at King Faisal in Saudi Arabia, and it turns out they had a whole pedigree with 5 individuals with a very similar phenotype, all had normal hearing, to the case that David Sweetser had. And so essentially a match was made. Now, it's very similar to our matchmaker exchange, but now using ClinVar as the platform for matching. And in the end, what they found, and I'll just skip to the punchline, basically there's 2 different mechanisms. One's a dominant gain of function that is the basis for the hearing loss. In this case, this is a recessive loss of function. So it's a new phenotype with a new mechanism that is now the basis for both this case and the other cases that had not yet been published but are now published. And in fact, 20% of the discoveries made by the Centers for Mendelian Genomics, which the Broad is one of them, are actually phenotype expansions. So a gene that's already known to cause one disease then gets associated to a new disease. So the last topic I want to talk about is just the role that patients play in genomic data sharing ecosystem. And we've been very active in ClinGen as well as Matchmaker Exchange in trying to engage patients. This is actually a 1-page consent form that Danielle and Aaron led the effort on in terms of having a very simple 1 page that either a clinician or a clinical lab could attach to their rec form. They actually have videos that they've made to explain different concepts in this one page at the patients, and they've done a lot of work with focus groups to get this consent form understandable and acceptable to the community. So that's on our website and can be used if patients, even in the routine course of clinical care, just want to share their data. Here is a real live case that I had actually last summer. A patient was actually pregnant, and prompted by increased nuchal translucency, had panel testing for RASopathy genes, which revealed a VUS in the BRAF gene. The couple was considering termination based on the VUS, just simply the uncertainty of what this result may indicate. However, they were savvy patients, more savvy actually than the clinicians involved, and this patient reached out to the labs that had submitted to ClinVar, one of which is my lab, and asked, what do you know about this variant? You know, I'm in this dilemma, can you share anything? So in the end, it prompted us to dig up our data. GeneDx was also involved. They dug up their data. The patient then had their own case. They got the father tested, who actually had the variant as well, but was normal. And through the aggregation, although just that one observation wouldn't have been enough to rule out a RASopathy, because there are, you know, somewhat unaffected parents that can pass a variant on. But we had enough cases through all three of these sources that we were able to reclassify the variant as likely benign. The couple continued their pregnancy and had a healthy baby last fall. We then updated our ClinVar entry. The family gave us permission to include the actual patient observation in this, and we've actually now published a little case story on this variant as well in molecular case studies. And we're able to update the variant. So a really nice story, all prompted by the patient's involvement in this effort. Now, it's a little bit difficult for other laboratories to deal with lots of patient inquiries. It's easier, actually, if the patients just share their genetic information with Genome Connect. We have a whole system to allow patients to put their health information, their genetic variant information. We submit their variants to ClinVar for them. We submit them as phenotyping-only submissions to not be confused as the laboratory submissions. So they're sometimes an adjunct to what the lab has already submitted, but it gives much more detailed phenotype directly from the patients. And we now have 731 variants that are in ClinVar. Over half of them, or almost half of them, were not yet in ClinVar when we submitted these. Though interestingly, in launching this project, we then discovered that sometimes the patient's own report is in conflict with the laboratory's current interpretation in ClinVar for those that are already in ClinVar, which then created the dilemma. Do we tell that patient, gee, we think the lab that did your report no longer agrees with the interpretation that you have? So Jules and the rest of the team with Erin and Danielle have been interacting with patients to understand their wish to get updated information. As you might imagine, 99% of these patients would want to learn about these updates, and 99% of them want Genome Connect to deliver those updates for them. Most of them will take any update, others only maybe those that may affect their care. They do believe patients should have the option to decline getting the updates if they wish, although most all of them want it. And so we are now giving the updates. However, we are doing it only when the actual lab that interpret our patient from Genome Connect's result has changed it. So it's lab A says it's likely benign now, but the patient has a report that says VUS, for example. If the patient has opted to getting those updates, we will then alert the reporting laboratory that we're doing this and directly email the participant. However, in this circumstance, where lab A still classifies the variant as VUS and it's other labs that differently interpret it, we are not yet engaging because we don't know who's right or wrong here if we don't go in and do the variant assessment ourselves. So right now, we're encouraging laboratories with these discrepant interpretations to address those through the variant interpretation discrepancy resolution group. And we don't directly share those yet with the patients. However, we've been facilitating this, getting these prioritized, given that the patients are clearly not informed of their current interpretation. And there have been now 22 of those that have been addressed. 8 were resolved, 3 were partially resolved, and 50% haven't yet been resolved in terms of between the laboratories. Those will then get pushed to the expert panels for further resolution efforts. So I think I just wanted to say one last bit about patient-initiated matching. So of the Matchmaker Exchange, we do have MyGene2, which is the UW site, actually has the ability for patients to upload their own candidate genes that they may have gotten back from clinical laboratory testing, for example. And there are 1,581 families that have uploaded their candidate genes onto the MyGene2 website, and those are now matchable on the Matchmaker Exchange. And there's been at least one discovery and publication from this platform to date. You don't need any IRB or consent if it's the patient doing it themselves. So it's one of the beautiful things. And I will say a lot of this patient-launched data sharing of this type was in part spurred by a very vocal father, Matt Might, who posted a number of years ago, a startling hunting down my son's killer sort of ad on the internet that ultimately led to actually solving his son's disease, and this has been written up in the New Yorker and so on. So I did post my slides onto the website. You're welcome to follow up. And there is one more video, but I think, I can't see what time it is. We have about 10 minutes, but I think we should leave that for questions. If you actually want to see our video with Matt Might telling his story, you can click on the link in my slide in the talk that is posted on the Google Doc drive. And with that, I will stop there and answer any questions. There's got to be some questions out there. Yes.
I'm Beth Shidley from Boston Children's, and this might be a stupid question. I don't know.
I'm sure it's not.
But I feel like, so I work in epilepsy genetics, and I feel like every new diagnosis we make, it's a new set of information, a new gene, there's no support resources, that there's no sort of guide for a lot of these families for kind of next steps. And I'm finding that we're creating a lot of these things ourselves, sort of resources, cheat sheets about what do you do, where do you go, where do you put your information, who do you connect with, and to a certain extent, for some of the gene-specific stuff, it has to be specific to that family. But is there anything, or are you developing anything that's sort of a guide to some of these things where parents can, more general ones, where parents can put their own information in, something that genetic counselors could give to families, aside from what we're already giving them?
Yeah, it's a great question. And I will say we've, to some extent focused on more of the infrastructure that supports the laboratories and the clinicians in terms of sharing data, making discoveries, interpreting variants. Though through, Genome Connect, through the MyGene2 effort, there are efforts to act, and our Rare Genomes Project, efforts to actually engage and educate the families, and that's through both videos, content to read, different information. I will say one of the challenges, now that we're tackling diseases that are truly N of 2, N of 3 diseases, like creating a lot of resources for a disease that might have 5 people around the world that have it is a huge challenge. And it's very difficult in a lot of times to even generalize that information and actually answer the questions. And what we find is the best resource for those families is another family. And sometimes, family 1 has a newborn, but family 2 has a kid who's 12. And in fact, they've been through those 12 years already and can share with the newborn, the family with the newborn, what they went through and what exactly happened with their kid throughout that. And not every presentation, as we all know, is identical across families, but as you get a network of multiple families that can share information, in fact, one of the little things that led Matt Might to find the other families was that his kid didn't generate tears, and that probably wouldn't be the top thing a clinician's going to enter into the most important phenotypes, or even potentially notice that a kid doesn't generate tears. But that family knew exactly that, and that was one of the key features that matched the families that networked. So I think, although it's not a perfect solution, and trying to give some of these families general guidance to general resources is useful, and some of the rare disease advocacy groups are trying to provide more general stuff, and linking up with the rare disease advocacy groups can provide some generalized resources, but I also think the connection patient to patient and family to family is often some of the most valuable.
I totally agree with you. I guess I'm thinking more about, I don't think the families even understand sometimes. We spend a lot of time kind of explaining, well, what are all these different databases that we're using?
Yep.
What is a population database? What is a functional database? And
Yep.
so even things that just kind of explain how we as clinicians and researchers are vetting their genetic information,
Yep.
how we go about interpreting it so that they understand, how we go about looking at variants.
Yeah.
I think that's more what I'm thinking about.
Yeah, and I've certainly given some lectures to lay community, groups, and we have an education group through ClinGen. So there are venues, but it is difficult to reach every patient out there. So I think we need, lots of groups in every, hospital and site, and to some extent, if we can generate the teaching materials and then disseminate, so everybody doesn't have to create their own. And that is some of the stuff that we are working on, is trying to create some generalized resources, like that video for consent we've posted on our website, and it explains, why would I want to share my data or not? What are some of the risks? That's a posted video, publicly available, and different sites, genetic counselors, let's say, that's talking to a family about, should I share my data or not? They can just point them to that video to go listen to the information in a much more user-friendly, consumable way than a 17-page consent form that no one likes to read. So we are trying to generate some of that stuff on our side for some of the types of resources we use, so that not everybody has to reinvent the wheel, and we'll have some guidance there. Yeah, that's a great question.
Thank you. It was a great presentation. I'm a clinical genetic counselor, so certainly we're talking about the pros and cons a lot with every patient, and I think everyone here can agree the benefits of sharing information are huge, but I'm curious what you would say to a patient who has more concerns about privacy breaches than benefits.
Yeah, and as we point out in that video, we can never guarantee that any patient's data will never get out there in ways they may not want. And what we really talk about are the risks and the benefits, and allow each person to weigh those things. And most of the families in the rare disease setting, the benefits for them are so outweighing whatever potential compromise if their data were to get out in an identifiable way, that those are usually easy decisions for most of the rare disease patients. It is a little harder for, we're also trying to enroll patients who are healthy, who just will share, everything. The benefits are a little harder to sort of explain. How is this going to help me? I'm a healthy individual, and what if my data gets out there and that it turns out they found out that I had a psychiatric admission, right? So those are very real and scary things to individuals around, will my data get compromised and become identifiable? And we do our best to educate, but at the end of the day, that's a decision that each individual has to make for themselves. But for example, the All of Us program have a lot of videos that when you go through the consent process, for those of you who have signed up for the All of Us program, where they do try to realistically explain, what those things are. And we do the same thing in our Genome Connect video to try to explain, what we can and can't control, how to try to be more secure. You know, don't put your entire genotyping profile on Ancestry.com. You know, that'll make it more likely that you can be linked in some way through a family member. But those are, you know, it's a great question, but not a perfect answer.
Thank you.
Yep.
Hi, my name is Jordan. I'm a laboratory genetic counselor at Johns Hopkins, and we have a lot of data. We haven't been sharing a ClinVar because of our consent,
Yep.
And we have a lot of data from previous years on rare diseases that I think would be really beneficial to share,
Yep.
but we really have no way of going and backtracking and getting consent from those patients to share data. Do you have any advice about how to deal with that?
I do have some advice. We have written a publication, and it's on our ClinGen website, that documents the fact that you do not need consent to share your opinions of variants. They are your opinions of variants. If you decide a variant is pathogenic, that's your opinion. It's not patient data. So you can submit your classifications to ClinVar. We also, in that article, go through and sort of define example evidence summaries that can accompany your classification and still be not considered patient-level data that requires consent. So of the 22,000 variants that my lab has submitted to ClinVar, I do not have consent for a single one of those cases to share patient-level data. I'm sharing my opinion of the variant, or someone in my lab's opinion, and the summary of evidence, which sometimes does say detailed things like, I found this variant in 3 patients with hypertrophic cardiomyopathy, 2 with dilated cardiomyopathy, and 1 with, left ventricular whatever. So that detail is in there, but in a summarized form. And so we've gone through and very specifically articulated the kind of summarized data that's okay to share without patient consent versus, and in fact, that video on the one-page consent defines the difference in the type of data that we share without consent, where it's sort of all summarized, and you can't tell that, we might say this variant was found in 3 Asian individuals and 1 Hispanic individual. And then we'll also talk about the phenotypes, and we don't necessarily say that Hispanic individual was the one with this, and that was this one. Whereas the consent for patient-level sharing, we then say we could then share that there was a 12-year-old Hispanic individual who had, dilated cardiomyopathy and also had these 2 other variants identified in their test. And so we differentiate the level of detail that we would share if the patient gave us consent versus sort of that summarized aggregate if I'm just sharing the classification and the evidence to support it. It doesn't require consent. Does that kind of address it? Yeah. It's a great question. All right. We have 2 more minutes. Any last remaining questions before you get your break? We have one more thing before they get. Okay, we're going to turn it over to Sam to use the last 2 minutes. Sorry.